Hey guys. Hey guys. Hey guys. Hey guys. Hey guys. Hey guys.
Hey guys.
Are you guys getting annoyed yet with the way we start this?
Hey guys. Hey.
We don't care. All right, so if you look at example number 1, you should quickly notice that we actually have this 6 in the front. Oops. We have the 6 in the front, and we are going to distribute that 6. All right, so 6 times x is 6x. 6 times -5 is -30. Well, this is something different. We have not seen this symbol before. That is called an inequality. Normally we see an equal sign there, but we're just going to, for right now, pretend that that is an equal sign and just keep solving, okay? So this is just solving inequalities. All right, so we have 6x here. Draw our line down. Who do we want to move? We're going to add 30 to both sides. And we get 6x is greater than or equal to 30 plus 30 is 60. So I'm going to then, remember, I want that x all by itself, and 6 and x are being combined with multiplication, so I'm going to do the opposite and divide. So what I get here is x is greater than or equal to 10. Now, if I needed to come up with some numbers that would make this inequality true, could I put 10 in for this x? Is 10 greater than or equal to 10? The answer would be yes, because we have this part right here that says equal to. So make sure you understand what these inequalities mean.
All right, so if we were to express the solution set in words, set notation, and graphically on a number line, just like we did back in lesson 7, it would look something like this, okay? In words, you would say x, right? We would take this inequality and translate. This x just stands for all numbers, or any number, so all numbers. The inequality sign is greater than or equal to.
How'd you know it was equal to?
Because it had a little line underneath it.
Thanks for the clarification.
Greater than or equal to. And then the number that we have is 10. Okay, that's how we would describe it in words. Now, in set notation, okay, this might be a little bit easier to set up if we can do our number line. I like to read it off of the number line. So I'm going to jump over to the graph real quick, okay? Our solution here is 10. I'm just going to put a couple numbers above and a couple numbers below. I don't have to start my number line at 0 every time. I like to put the solution in the middle, okay? Let's see, we need a circle on 10, so we're going to have an open or a closed circle.
Close, because it's included or equal to.
Very good. And remember, this greater than symbol should serve as the head of the arrow, okay? So our arrow is going to point in this direction. Now, when I do my set notation, I like to read my number line from left to right. So I do my set notation like this. Where does this set start? Okay, it starts at 10. Is that 10 included in the set? Meaning, is there an open or is there a closed circle there? Okay, so it is included, so I put a square bracket. Then, where does my set end? Okay, let's see. This arrow means that it's going to keep going on and on and on forever, so it's ending at infinity. And remember, we use a round bracket with infinity because it is not included. Okay? All right, so jumping into example number 2. Again, we solve inequalities the same way that we solve equations. So we are going to pretend that this inequality sign is an equal sign. So draw our line to start our inequality. So I'm going to distribute this 3 to everything in the parentheses. That will leave us with 3x plus 9 is less than or equal to 5x minus 3. All right, I want you guys to pause the video here, take a second, and try to work out this problem. Just like how we practice solving equations in lesson 8, you're doing the same thing here with this inequality. Okay, so take a minute, check your work, and see if you got the same solution. Now, talking about this solution set, 6 is less than or equal to x, okay? So what does that really mean? 6 on the number line is less than or equal to all of the x values that we're talking about. So 6 is the smallest number on this number line. All the other numbers have to be greater than that, okay? So think about what that means. So to answer the next question here, state the smallest possible value for x in the solution set, okay? What would it be?
What is the smallest value we could put in there?
6, okay? Again, thinking about what this inequality is telling us. It's telling us that 6 is less than or equal to all the other numbers in the solution set. So 6 is the smallest possible number, okay? All right.
Okay, the next one. All right, so we've seen things like this. We're just going to solve this equation or inequality. I want this negative a by itself, so I'm going to move that 6. I'm going to subtract 6 from both sides. I get a negative a is greater than or equal to 9. Now, if you notice, are we allowed to have this negative sign right here in front? You should be saying to yourself, no. And I know with some of our classes, we've shown you guys ways to get rid of that negative. We're going to divide each side by a -1. But here's the thing, when you divide by a negative, anytime you are dividing an inequality by a negative, you take this sign right here and you have to flip it. So the open mouth is going to turn this way. And then everything else just kind of comes down.
Okay, so again, the directions say just to verify or make sure that your solution is true. How could we do that? Let's see, our solution set is saying that a is less than or equal to -9. So all the numbers in our solution set have to be less than -9. Pick a number that's less than -9. Let's try -10 and plug it into your original inequality and see if it works.
Is -10 less than or equal to -9?
Yes. Okay? That's all you have to do. Just make sure that your solution works.
All right, the next one. This should look familiar. We're going to cross multiply. What's -x times 4? -4x. What's 12 times 1? 12. And then you're just going to bring that sign over. Again, see how we have that negative? That automatically tells me that this sign right here is going to flip. So I'm going to divide each side by my -4. These cross off. I've already flipped the sign and I get -3. So it's saying x is greater than or equal to -3. Could I put a -3 in there? Could I say -3 is greater than or equal to -3?
Yes.
Yes. Yes, I can. So the inequality rule is
When you divide by a negative. Okay, so see how we were dividing by this -1 in this equation? We're dividing by this -4 in that equation. Anytime you divide by a negative, you have to flip the inequality sign. Okay? All right, if you guys have any questions, ask a teacher, work with each other, check your classwork when you're done. Good luck.
good luck.